Halogen derivatives of aromatic hydrocarbons, preparation of bromobenzene, to 15 grams of benzene in a 200 centiliters flask, add per 35 centiliters, that is about 105 grams of bromine. Fill the flask with a cork stopper throughout which passes a glass tube bent twice at right angles. The longer arm of the tube which passes throughout the cork should be about 2 feet long. Place below the end of the shorter arm flask containing 100 centiliters of water to absorb the hydrobromic acid formed in the reaction. The end of the tube should be just above the surface of the water. Put the flask containing the benzene and bromine in a pail or a larger beaker containing ice water and add to the flask to clean iron tacks or nails. Allow the reaction to proceed until the next laboratory exercise. Wash the product with water and with a little sodium hydroxide if necessary until any excess of bromine has been removed. Place the liquid in a separatory funnel, separate it and dry it with anhydrous calcium chloride. Fraction it 3 times. Collect the following fraction: up to 120 degrees, 120 and 115, 115, 116, 116 and 200 degrees. The fraction boiling at 115 degrees, 116 is practically pure bromobenzene. Calculate the molecular proportion in which reaction substances were used in the preparation and the percentage yield obtained. Determine the specific gravity of the bromobenzene. The residue boiling above 200 degrees contains p-Dibromobenzene. It may be poured while still hot onto watch glass and crystallized from alcohol. See directions on the preparation of the bromobenzene. Put the hydrobromic acid collected as a byproduct in the reaction into the bottle provided for hydrobromic acid residues. This preparation yields a large amount of hydrobromic acid, as 1/2 of the bromine used in conversion into the acid. On distillation, the aqueous solution yields an acid that can be used conveniently for the preparation of alkyl halides. Bromobenzene boils at 156 degrees and has a specific gravity of 1.491 at 20 degrees. The yield in this experiment should be from 16 to 65 grams. And note, in order to obtain a good yield of bromobenzene, it is advisable to keep the mixture of benzene and bromine cold during the reaction. The product obtained consists of a mixture of benzene, bromobenzene, and dibromobenzene. The effect of the temperature on the reaction is clearly seen by comparing the method used in this preparation with that employed to prepare the hydrobenzene. See the experimental below. Preparation of p-Dibromobenzene. To 5 grams of benzene in a small round bottom flask, add 10 centiliters of bromine. Close the flask with a cork throughout which passes a piece of glass tubing about 3 feet long to serve as a reflux condenser. Place the flask in the hood, drop into it a tack or piece of clean iron filling and allow the reaction to proceed spontaneously to completion. This usually takes about 30 minutes of an hour. Then heat the flask casually over a free flame for 2 minutes to expel most of the excess of bromine. Add about 15 centiliters of water and let it boil and shaking vigorously. Cool until the dibromobenzene solidifies and decant off the liquid. Repeat the washing with hot water twice, adding to the liquid the last time about 15 centiliters of a solution of sodium hydroxide. Cool and wash the crystals once more with cold water. Decant off the water. Add the 75 centiliters of alcohol and a little bone black and heat to boiling. Filter the hot solution and add the 20 centiliters of water. Set aside to crystallize. Separate the crystals and determine their melting point. Calculate the percentage yield obtained. P-Dibromobenzene crystallize in colorless leaflets which melt at 80-90 degrees and boil at 290 degrees. The yield should be about 13 to 14 grams. Properties of aromatic halogen compounds. Solubility of halogen compound. For example, determine whether bromobenzene is soluble in the following: water, alcohol, ether, concentrate sulfuric acid, dilute hydrochloric acid, and solution of sodium hydroxide. To test inflammability of halogen compounds, wrap a strip of copper gauze about 1 cm wide around a piece of wire to serve as a handle, so that roll about as thick as a lead pencil is formed. Pour a few drops of the liquid or place a few crystals on the gauze and place it for an instant in a flame. Remove the gauze and note whether a soot is formed by holding the burning substance in front of a piece of a white paper. Determine whether the following substances burn and whether soot is produced: benzene, bromobenzene, p-Dibromobenzene, benzyl chloride, ethyl bromide, chloroform, carbon tetrachloride. What conclusions can be drawn from the experiment? Comparison of the behavior of compounds containing the halogen joined directly to the benzene ring with those containing the halogen in a side chain. Read carefully. Section 47 and 1418. Compounds of the two classes behave differently with an alcoholic solution of potassium hydroxide. In order that inclusive results may be drawn from the test, it is necessary to have a solution of the alkali which is free from halogen. As all samples of commercial potassium hydroxide contain potassium chloride, prepare solution by dissolving about 1 gram of the hydroxide in 20 liters of about alcohol in absolute alcohol. Filter from the undissolved carbonate and chloride and use the clear filtrate for the tests. Test a part of the solution, so prepare for halide as follows: dilute with water, acidify with nitric acid and add acetyl nitrate. Add 3 drops of benzyl chloride to 5 cm of the alcoholic potassium hydroxide solution and boil gently for 2 minutes. Dilute with the water, acidify with pure dilute nitric acid and add a few drops of a solution of acetyl nitrate. Repeat the experiment using bromobenzene in order not to confuse with silver bromide. The loudness produced when the bromobenzene is precipitated from the alcoholic solution by the addition of water. Add 3 drops of bromobenzene to 5 cm of alcohol and dilute with the amount of water used in the test. Compare the appearance of the solution with the one which was heated. If the unchanged precipitated organic halogen compound interferes with the observation of the silver halide, it can be removed by shaking the solution with ether and adding the silver nitrate to the clear aqueous solution. A solution which can also be used for the test may be prepared by dissolving about 0.5 gram of clean sodium free from any crust in 20 centiliters of alcohol and adding a few drops of water. Note: in applying this test, it is necessary to determine first whether the compound contains any free halogen acid, which has been produced as the result of decomposition of unstanding. Shake a little of the substance with water and test the aqueous solution with the silver nitrate. If a precipitate is formed, the halide must be washed with water until the latter gives notice for halides. Preparation and properties of triphenylchloromethane. Attached to a 500 cl flask by means of a stopper, a small drying tube containing anhydrous calcium chloride. Provide a beaker containing cold water into which the flask can be sunk up to the neck and held in place by a wire. Add to the flask 1 grams of carbon tetrachloride, 7-8 grams of benzene, and 28 grams of anhydrous aluminium chloride in the form of lumps. Let the flask stand in hood for at least 24 hours. In a beaker, place 100 grams of shaved ice or snow and add 100 centiliters of concentrated hydrochloric acid. Pour the mixture into the flask, add 15 centiliters of benzene, shake the flask under running water until 2 distinct layers are formed. Separate the upper layer with the aid of a separator funnel and add to it about 5 grams of anhydrous calcium chloride. Shake the flask to bring the drying agent in contact with any water present. In about 5 minutes, fill the solution into the flask and distill on a boiling water bath as long as any liquid passes over. Pour the contents of the flask into a beaker and add to the flask 100 centiliters of petroleum ether and pour the latter into the beaker. The next tie filter of the crystals by suction. Disconnect the flask from the pump, add 25 centiliters of petroleum ether and in a few minutes roll off the liquid adherent to crystals. Repeat the proportion with another 25 centiliters portion of petroleum ether. Spread the crystal on a paper to dry and with them. Triphenylchloromethane melts at 109.11 degrees. It can be crystallized from boiling liquor in which it is readily soluble hot and difficulty soluble cold. Since triphenylchloromethane is decomposed when heated with water, another solvent should be used. The compound can be obtained in a very pure condition by crystallization it from the boiling acetyl chloride. The yield of the material obtained is 16% of the theoretical by sealing off the solvent from the first crystallization and adding to the residue 5 centiliters of petroleum ether and additional quantity of triphenylchloromethane can be recovered, which increases the yield to 75%. Note that if the dark red oil, which separates at first in the reaction, is decomposed at once by water, mesophenone chloride, C6H5 2CCl2 is obtained. This red oil, which is a molecular compound of mesophenone chloride and aluminum chloride, reacts on standard with Bromobenzene and is converted into a substance of decomposition, which is a crystalline solid. Water decomposes this addition product into its constituents. Reaction with water. Powder about 0.1 gram of triphenylchloromethane and shake it in a test tube with water. Let the mixture stand a few minutes and then test the aqueous solution for hydrochloric acid with litmus paper and with silver nitrate. Reaction with sulfuric acid. In a small beaker, treat about 2 grams of triphenylchloromethane with 5 centiliters of concentrated sulfuric acid and shake until the solution is complete. Is hydrogen chloride given off? Compare results with those obtained with ethyl bromide. Pour the solution into 5 centiliters of water, filter off by suction the precipitate of triphenylcarbinol, wash with water and dry it. Add a small amount of the carbinol to a little concentrated sulfuric acid on watch glass. Grind thoroughly some of the carbinol in a mortar with a little concentrated hydrochloric acid for about 1 minute. Remove the product with a spatula to a porous plate and let it dry. Add the compound to a little concentrated sulfuric acid. Precaution for all reactions which take place. Reaction with silver nitrate. Dissolve a bit of triphenylchloromethane in a little acetone and add an alcoholic solution of silver nitrate. Reaction with metals. Repeat experiment of page 137, experiment 168, preparation of triphenylmethane from triphenylchloromethane. When the dish product of triphenylchloromethane and aluminum chloride is treated with ether, the halogen atom in the former is replaced by hydrogen attached to a 215 cl flask by means of a cork, a drying tube containing anhydrous calcium chloride, a beaker containing cold water into which the flask can be sunk up to the neck and can be held in place by means of wire. Add to the flask 29 grams of carbon tetrachloride, 73 grams of benzene and 25 grams of anhydrous aluminum chloride in the form of lumps. Place the flask in water and let it stand at least 24 hours. Connect the flask with a return condenser. Place it in water and add throughout the condenser 30 grams of ether. Shake occasionally and let the mixture stand at least 24 hours. Pour the mixture onto 200 grams of ice and 5 centiliters of concentrated hydrochloric acid. Add 100 centiliters of carbon disulfide and shake until 2 layers have formed. Separate and dry the oil with calcium chloride. Filter into a flask and distill off the carbon disulfide. Transfer the residue to a small flask and distill using a short glass tube as an air condenser. Collect the fraction boiling between 1313 and 1356 degrees. Distillate, which should weigh about 33 grams, in dissolved in 135 centiliters of boiling alcohol. Solution is stirred as it cools. When cold, filter off the triphenylmethane by suction and wash twice with 10 centiliters of cold alcohol. Weigh the product after drying and adhere its melting point and calculate the yield from the carbon tetrachloride used. The yield should be about 16% of the theoretical triphenylmethane melts at 92